Chapter 1, Review Part 1. Lesson Objectives: Define sample, population, and individual. Distinguish between descriptive statistics and inferential statistics. Distinguish between anecdotal evidence, observational studies, and design experiments. Lesson Objective number 1. We'll begin with some definitions. The entire group of individuals to be studied is called a population. A sample is a subset, which means part of, the population that is being studied. And an individual is a person or object that is a member of the population being studied. So in statistics, we always want the sample to be representative of the population. Let's look at some more definitions. Qualitative or categorical variables allow for some classification of individuals based upon some attribute or characteristic. So some examples of qualitative data would be male and female. Another example would be eye color or favorite type of music. Another type of variable is called quantitative variables. These variables provide a numerical measure of individuals. Examples of this would be weight, height, distance away from school. So these variables provide numerical measures. They're numbers. Now with these numbers we can add and subtract and perform other operations, and the end result would make sense. So for example, Social Security numbers are not quantitative data because we can't take one Social Security number and add a second Social Security number and get a third. Quantitative data is data that are numbers that you can perform operations such as addition and subtraction, and the end result would make sense. If a variable is quantitative, it can be classified as one of two variables. We'll begin with the first one, discrete variable. So a discrete variable has a finite number of possible values or a countable number of possible values. Examples of this would be the number of students in a classroom or the number of teeth in a person's mouth. These are things that you count. The other type of variable is called a continuous variable, and it is a quantitative variable that has an infinite number of possible values. And basically this is normally measurements. So examples of this would be height and weight and anything involving time. So if it's something you measure, it's most likely continuous. If it's something you count, it's most likely discrete. Here's a little visual of our variables. We have categories here, qualitative variables, and then we have quantitative variables. These variables can be split into discrete variables, countable, and continuous measurements. Lesson objective number 2. Descriptive statistics consist of organizing and summarizing data. Descriptive statistics describes data through numerical summaries, tables, and graphs. This is what you learned previously. An example of numerical summaries would be X bar, the median, standard deviation. Tables could be frequency tables or relative frequency tables, and graphs could be histograms, pie charts, bar charts, box plots. Now the other branch of statistics, inferential statistics, uses methods that take results from a sample and then we extend them to a population. And they also provide measures of the reliability of the result. So we take information from a sample, something that we know about, and then we infer about a population, something we don't know about. So statistical inference. This is what we'll be doing in chapters 9, 10, and 11. And this is where we take information from a sample and we infer about a population, something that's unknown. Just to recall, a statistic is something that is measured from a sample. So this is information from a sample. And a parameter is information from a population. So we're going to use a statistic to infer about a parameter. Now in the next series of videos we'll talk about sampling variability, and that simply means as we go from sample to sample, the information from the sample will likely differ. And we'll also talk about, when we get into chapter 8, something called sampling distribution. That means a sample statistics will have a predictable pattern. So this is ideas that will be coming up in the future. Lesson objective number 3. Anecdotal data. A friend of yours says he will never wear a seatbelt again. He explains that an acquaintance of his survived a car accident because she wasn't wearing a seatbelt. The acquaintance flew through the windshield screen, landed on the grassy bank, and suffered minor injuries. Meanwhile, the car burst into flames and was destroyed. Should you wear a seatbelt from now on? Now, this is an example of anecdotal evidence. Anecdotal evidence is types of evidence that cannot be used to logically conclude something. We see this types of evidence all the time in commercials. A person tells us how their breath feels fresher after using a certain brand of toothpaste, or people testify to the clearing of their acne as a result of special products. Anecdotal evidence is used in place of many clinical or scientific evidence and may completely ignore research or harder evidence that points to an opposite conclusion. We take recommendations from non-experts all the time. We may base our decisions on which doctor to see, who should babysit our kids, what travel agency we ought to use, or where we should stay on vacation solely or at least partly on advice. This advice usually doesn't come from people who are qualified to give an expert opinion on the matter. Where anecdotal evidence gets very problematic, though, is when people make decisions that may affect their health or well-being based solely on it. For instance, there are many herbal medications and alternative medical theories and treatments that people decide to use largely based upon an anecdote. Here's the readings and suggested problems. Thanks for watching.